warahmatullahi wabarakatuh. Hi everyone, welcome back to my video. In this video, I'm going to invite you to discuss about momentum. What is momentum? Yeah, maybe this quantity is new for you. Okay, before we start the discussion, I would like to ask you a simple question. Have you heard about airbag in car? Do you know what's the physics concept behind this apparatus? Yeah, we know that the airbag is used to reduce the risk in an accident, right? So basically, this airbag can work using the concept of momentum. Yeah, to understand more about momentum, please keep watching this video until the end. So without further ado, let's just start the discussion. Okay, everyone, here we already opened the simulation collision lab. So I would like to show you how to calculate the momentum of an object, and I would like also show you how the momentum conserved in a collision. Okay, first let's see how we calculate momentum. In this simulation, here we have two objects. The blue one here, the blue ball, the mass is 0.5, and the pink ball here, the mass is 1.5. Alright, and in this simulation we can set the velocity. For the blue ball, the velocity is 1 meter per second, and for the pink ball, the velocity is minus 0.5. Okay, remember, velocity is a scalar quantity, so it has direction. When the sign is positive, so we can interpret that direction is to the right. So when the value is negative, that means the object is moving to the left. Okay, yeah. Now, and then okay, maybe before we calculate the momentum, let's run the simulation. Alright, yeah. So we see here that these two objects is moving in the opposite direction. The blue one moving to the right and the pink to the left. Okay, and then we can calculate the momentum. Basically, to calculate it, we only need to multiply the mass and the velocity here. Okay, in this simulation, the momentum for each ball has been calculated. But let me show you how the momentum here for ball 1 is 0.5. Okay, the mass is 0.5 and the velocity is 1. So to find the momentum, we can again just multiply the mass 0.5 times velocity 1. So 0.5 times 1 equals to 0.5. Okay, and then for the second ball, the pink one, the mass is 1.5 and the velocity is minus 0.5. So we got a minus 0.75. So the momentum for the second ball or the pink ball is minus 0.75, and the unit for momentum is kilogram meter per second. Okay, yeah. So we know that momentum is a quantity that show how hard, yeah, in my simple definition, how hard we can stop a moving object. Yeah, if the momentum is higher, so it will be harder for us to stop the object. So from this value, so it will be harder for us to stop the pink ball. Yeah, since the magnitude is higher, because minus here is just show the direction. Yeah, so that means momentum is also scalar, vector quantity. Yeah. In the right panel here, we can pick the velocity arrow to show where the velocity directed to. Okay, you see here, and also the momentum. Yeah, so the momentum direction will be the same as the velocity direction. Alright, so I hope everyone understands how to calculate momentum of a moving object. Yeah, only multiply the mass of the object by the velocity. That's all. Yeah, but maybe before you calculate, please pay your attention to the unit. Yeah, make sure the unit for mass is kilogram and the unit for velocity is meter per second. So the unit for momentum will be kilogram meter per second or Newton second. Yeah, the same. Okay, if you already understand about momentum, let's discuss about collision. Yeah, let's discuss about collision. So here we have two objects, yeah, and they are approaching. So the blue one is moving to the right and the pink one moving to the left, so they will collide. And the momentum we have calculated before, and here the momentum for each ball. Okay, so if we find the total of momentum before they collide, yeah, 0.5 plus minus 0.75, yeah, it will be equals to minus 0.25, correct? Okay, again, so first of all, calculate the momentum before collision. Yeah, before collision. Momentum from object 1 is 0.5 here, and momentum of object 2 is minus 0.75. So the total will be minus 0.25. Okay, keep it in your mind. Yeah, the total momentum before collision is minus 0.25. Okay, and then now I would like to start the object collide each other. Okay, maybe I would like to choose the slow motion, yeah, so it will be better for us to analyze. Okay, they are approaching, collide. Okay, I pause. So now the condition is after collision. Now it's after collision. Yeah, after collision you see the mass still the same. Yeah, there is no change in mass, but the velocity you see now change. The first ball now velocity is minus 1.25. Minus 1.25, that means this ball is moving to the left. Yeah, because here the value is minus. And as we saw that after collision it's moving to the left, right? And see the second ball, the pink one. Yeah, the is 0.25. Now it's positive, that means the pink ball here is moving to the right. Okay, yeah, so the velocity change after the collision. And now let's calculate the momentum for each ball after collision. For the first ball, the mass 0.5 and the velocity is minus 1.25. So again, to find the momentum, we can simply multiply the mass and the momentum. So 0.5 times minus 1.25. So we will get minus 0.63. That's the momentum of the first ball after collision. Okay, and then next, we are going to calculate the momentum of after collision. The mass is the same 1.5 and the velocity is 0.25 here. So the momentum is 1.5 times 0.25. So we will get 0.38. So 0.38 is the momentum of second ball after collision. Okay, and then after that, let's to calculate the total momentum after collision. Yeah, the total momentum after collision, we have to add the momentum from the first and the second ball. So minus 0.63 plus 0.38. So it will be, yeah, you can calculate by yourself. So you will get minus 0.25. Get it? Okay, yeah. So the total momentum collision is the same with the before collision. Now, so from this simulation, we can show that the momentum before and after collision is the same. That means the momentum is conserved here. Yeah, the momentum is conserved here. Now, if the momentum is conserved and if the kinetic energy is also conserved, so we can consider that the collision is elastic collision. Okay, to see how the kinetic also conserved here, actually we can see the kinetic energy. Yeah, what we see here is the total kinetic energy from both ball. Okay, let me restart from the beginning. Yeah, this is before collision. You see the kinetic energy is 0.44 joule, and I run it. Okay, they are approaching, and yeah, after collision I pause, and after collision the total kinetic energy is still the same, 0.44 joule. Yeah, so again, if you have a collision where the total momentum before and after collision is the same and the kinetic energy also the same, that means momentum and kinetic energy conserved, so we can say that the collision is elastic. Okay, hopefully you understand, everyone. You can explore this simulation. Yeah, you can change the elasticity to inelastic. Yeah, in inelastic the kinetic energy will not conserve. Let me show you here.
Okay, thank you everyone for watching this video until the end, and that's all the discussion about momentum today. Hopefully after watching this video you have understand what is momentum and how the momentum conserved in elastic collision. Once again, thank you very much. Let's close this video by reciting hamdalah. Alhamdulillahirabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh. Bye everyone.